Welcome back! In our previous lectures, we covered different measures of central tendency like mean, median, and mode. These tell us the middle or average value of a dataset. But today, we will learn something new, measures of dispersion. This helps us understand how spread out the data is. Imagine a classroom where students' ages are very close to each other versus another class where ages vary a lot. Measures of dispersion tell us about this variation. What is dispersion? Dispersion means how much data values are spread out. If the values in a dataset are very close to each other, the dispersion is small. If they are very different from each other, the dispersion is large. Example: 1. Suppose you have test scores of 5 students. 80, 82, 81, 79, 83 scores are close, small dispersion. 2. Now another class has these scores. 50, 90, 30, 85, 100. Scores are very different, large dispersion. Understanding dispersion helps us know how consistent or inconsistent the data is. Types of measures of dispersion, there are 2 types. 1. Absolute measures. These give actual differences in data values. 2. Relative measures. These compare dispersion between different datasets. 1. Range is the simplest way to measure dispersion. It is the difference between the highest and lowest value. Formula: range equals sign, highest value, lowest value. Example: suppose you have the numbers 10, 20, 30, 40, 50. 1. Highest equals sign 50. 2. Lowest equals sign 10. 3. Range equals sign 50. 10 equals sign 40. Range tells us how wide the data is spread but does not consider all values. 2. Coefficient of dispersion. It is used when comparing dispersion between different data sets. Formula: coefficient of dispersion equals sign highest, lowest, highest plus lowest. Example: for the data set 10, 20, 30, 40, 50, we calculated range equals sign 40. Now, using the formula 50, 10, 50 plus 10, equal sign 40 60ths equal sign 0.67. A higher coefficient means more dispersion. 3. Quartile deviation. Quartiles divide data into 4 equal parts. Quartile deviation measures dispersion between the first quartile, Q1, and third quartile, Q3. Formula: quartile deviation equal sign Q3, Q1. 2. Example: for the dataset 10, 20, 30, 40, 50, the quartiles are 1. Q1 equal sign 20. 2. Q3 equal sign 40. 3. Quartile deviation equals sign 40, 20, 2 equals sign 10, 4. Coefficient of quartile deviation. It compares dispersion in different datasets using quartiles. Formula: coefficient of quartile deviation equals sign Q3, Q1, Q3 plus Q1. Example: using Q1 equal sign 20 and Q3 equal sign 40, 40, 20, 40 plus 20 equal sign 20 60ths equal sign 0.33. A higher value means greater dispersion. Quick revision. 1. Dispersion tells us how much data values vary. 2. Range is the simplest measure, highest, lowest value. 3. Coefficient of dispersion compares datasets. 4. Quartile deviation checks how spread out the middle 50% of the data is. 5. Coefficient of quartile deviation compares different datasets. Final exam tip. 1. Learn the basic formulas and practice solving simple problems. 2. If you remember how to calculate range, Q1 and Q3, you can easily find other measures. That's it for Lecture 27! In the next lecture, we will explore mean deviation and variance, which are more detailed measures of dispersion. Stay tuned for that! If you haven't watched the previous lectures, check them out because each topic builds on the previous one. Happy studying!